Hello, welcome to my new tutorial. Today we're going to make our 3D game objects to follow a UI element. Let me just hit play so you can see it in action. As you can see, our three spheres move to our UI element on the screen. This is really useful if you are making a 3D game where you have to collect stuff like power-ups or enemy souls and so on. Here's a game where I used this effect. See the orbs going to the UI. Really cool. Now I'm going to create a new scene so we can make this from scratch. Okay, just create a new scene. Now we need a canvas with a UI element inside it. Let's make one canvas. Let's make it scale with screen size, and let's add the UI image inside it. I will enter it to the top right corner of the screen like this. So if we resize our screen, it stays there and resize with its size. Now let's create a 3D sphere. That's the sphere that will follow our UI element. Let's reset its position. Okay, now that we have everything we need in the screen, I'll explain how our algorithm is going to work. First of all, we need to find the ending position for our sphere that is behind the UI element. I'll just duplicate our sphere here and name it target so we can easily visualize the position we have to calculate. So that's it. We need to move our sphere from here to here, so you can see it will slide along an invisible plane here. Let's create a plane so it's easier to visualize. Okay. Let's increase it just a bit. Okay. So we need to move our sphere here, along this plane, so it ends up here behind the UI element. The first problem is that our 3D objects positions are given in world coordinates and our UI elements are given in screen coordinates. So the first step would be to get the UI elements position in screen coordinates. To do that, we need to cast a ray from our camera that goes to our UI element, and then we can compute the intersection of this ray with the plane behind it. Okay, just to be clear, this plane here is just for visualization. We actually don't need a physical 3D plane to compute the intersection. So I will disable it, and we also don't need the target sphere. Okay, let's create our script then and start scripting. Let's call it follow UI. Okay, first let's grab a reference to our UI element, including unit UI, and declaring a public variable rect transform UI element. Okay, we also need a private variable that will hold our ending position. Now we need to get the screen coordinates for our UI element. We can do that by accessing its rect, and let's get from the center. There's a catch here because this position is given in local coordinates and not in world space. That means this position will be referent to the object's pivot. So we need to make a conversion. We can do that by calling the transform point function. Transform point. As you can see here, transforms position from local space to world space. That is exactly what we want. Okay, let's put it to a local variable, vector3 screen pos. Okay, now we need to create an array that goes from our camera to our screen position we calculated here. To do that, we can access our camera and call the screen point to array function, passing our screen post as argument, like that. Let's put this array in a variable. Okay. Now we need to calculate the intersection of array with that invisible plane I explained earlier. To do that, we can create a new plane, and for that we need a normal and a point for the plane. Since our plane should be always facing the camera, we can use the camera forward vector as our plane normal. We can do that by accessing our camera transform and forward. But in that case, it should be the negative forward because it should be facing backwards, and the position should be our object's position. So we can do that by calling transform position. Now that our plane is defined, we can call its recast method, passing our array as parameter. We can also see that it needs an outfloat parameter. That means it will be written inside the function with a value. This value is the distance from the beginning of the array to the intersection point. So we need to declare a new variable here. Let's call it dist and initialize it with 0, and a pause here with the out keyword dist. Okay, now with this distance value here, we can calculate the intersection point of array and the plane we defined here in world coordinate. To do that, we use array and call the getPoint method. The description says returns a point at distance units along the array, and we pass our dist variable, since this is the distance from the beginning of the array and the intersection point. Now we just need to put this in our ending position variable, and that's it for the first part. Now we just need to move our object to this ending position, and we can do that inside the update function. First, we check if the transform position is different from our final position. If it is, we have to move it towards the position. We can do that by using the smooth temp function from the vector3. Vector3 smooth temp. This function makes a nice interpolation between the current position and the target position. So the current position is our transform position, and the target position is the ending position. We also need a variable to keep track of the velocity. We can do that here. Okay. We need the ref keyword, and we also need a smooth time that will control the speed of our interpolation. Let's create a public float smooth time. let's put 1 for now, and I think that's it. Oh, I just missed one parenthesis here and not here. Okay, let's test it, check if it's working. We have to drag a reference for our UI element here, and now we just hit play and see if it's working. Yeah, it seems to be working as expected. Really cool. We can also make another copy of the sphere too and change the position so we can make sure everything's okay. Let's make another one in position more in front of the camera, like this. Let's test again. Yeah, cool. No matter the position of the sphere, it's always go to the UI element. We also can change the camera and should be working fine. Okay, that's it. If you have to collect stuff in your 3D game, this makes a nice effect. If you like the video, please like and subscribe, and thanks for watching.